Welcome to another CS31 lecture video. For this video, pag-aaralan natin ang isa sa mga pinaka-popular na type of path or circuit sa graph theory. So, definition: a simple path in a graph G that passes through every vertex exactly once is called a Hamilton path. And the simple circuit in a graph G that passes through every vertex exactly once is called a Hamilton circuit. A graph is said to be Hamiltonian if it has a Hamilton circuit. Kung ang isang graph represents a town, for example, itong graph na to, ang bawat vertex ay bahay and ang bawat edge ay street. So, pwedeng mong isipin na yung Euler path or Euler circuit, gusto mong daanan lahat ng streets. Kapag naman Hamilton circuit, ang gusto mo madaanan lahat ng bahay. So, ang isang application, kunwari, salesperson ka, tapos gusto mong magbenta ng product, syempre, ang gusto mo, lahat ng bahay, madadaanan mo para mapagbentahan. And para tipid sa oras, gusto mo, dadaanan mo lang sila once. So, for this graph, meron ba tong Hamilton path? So, recall na kapag path, hindi kailangan na pareho yung simula at dulo. Okay? So, pwedeng Hamilton path is from A to B, then C, then G, and then F, then E, then D, H, I, J, K, N, M, L. Yan. No? Ano naman ang example ng Hamilton circuit? Yung dadaanan mo lahat ng vertex, tapos yung kung saan ka nagsimula, dun ka rin matatapos. So, let's say, from A, pwedeng A, and then B, and then H, and then L, M, N, K, J, I, E, F, G, C, B, and then back to A. So, since ito ay may Hamilton circuit, ibig sabihin, itong graph na ito ay Hamiltonian. Question: itong graph na ito, Eulerian ba? Ang sagot ay hindi. Bakit? Kasi marami kang mga vertices na odd degree, no? So, si B, si D, si G, si K, and so on. At hindi rin siya, wala rin siyang Euler path, no? Kasi more than 2 yung may odd degree. So, anong mapupulot natin mula dyan? Mapupulot natin na hindi dahil Hamiltonian ang isang graph ay Eulerian din siya. Kung Eulerian ang isang graph, masasabi ba natin na Hamiltonian siya? So, kapag Eulerian, kailangan natin ma-visit lahat ng edge. So, yes, ma-visit natin lahat ng vertex. Pero, pwede kasing ma-visit natin more than once ang vertex. Depende sa degree ng vertex. So, dahil dyan, di rin natin masasabi na kapag Eulerian ang isang graph ay Hamiltonian din siya. Just like in Eulerian graphs, we are interested in finding out what criteria can we use to determine whether a graph is Hamiltonian or not. So first, we profile the property of a Hamilton circuit, and we have the following theorem. If C is a Hamilton circuit in the graph G, then C covers exactly 2 edges incident to each vertex, and C has no subgraph, which is a simple circuit on fewer than the number of vertices. So here's the example graph we had earlier, and this is a Hamilton circuit for the graph. So, ang property ng isang Hamilton circuit according sa theorem, lahat ay may vertex na of degree 2 at walang mas maliit na circuit na subgraph nitong Hamilton circuit. So, it seems obvious, no? But what is good is we have some criteria to say that a graph is not Hamiltonian. So, let's apply this theorem. So, let's consider this graph. Note that E, D, and A are all of degree 2, right? So if we are to generate a Hamilton circuit for this graph, we have to include all the edges incident to these vertices. So ito yung mga naka-highlight dito. Ang problem lang ay ito, itong simple circuit na ito. So, kung bubuo tayo ng Hamilton circuit at involve itong mga edges na ito, magkakaroon tayo ng smaller circuit na subgraph ng Hamilton circuit, which is not possible according to the theorem. So, dahil dyan, hindi ito Hamiltonian. Here we have another example. Ganun din, no? Kita natin si 6, si 2, at saka si 4, all these vertices have degree 2, right? So we have to include their incident edges. Pero, with the inclusion, makakaabuo tayo ng smaller simple circuit, which cannot be part of the Hamilton circuit that we want to create. So, ibig sabihin, it is not possible to create a Hamilton circuit for this graph. So, ito ay hindi rin Hamiltonian. If a graph G is Hamiltonian, then G has a subgraph H with the following properties. H contains every vertex of G, H is connected, H has the same number of edges as the number of vertices, and every vertex of H has degree 2. So this is another theorem that we can use to determine if a graph is not Hamiltonian. No? So pwedeng kunin lang natin yung contrapositive. Kapag walang subgraph with these properties, then ang graph ay hindi Hamiltonian. Here we have two theorems. These theorems state some sufficient conditions to show that a graph is Hamiltonian. So, first theorem, Orr's theorem, if G is a simple graph with at least 3 vertices, such that the degree of U plus the degree of V is at least n for every pair of non-adjacent vertices, then G has a Hamilton circuit. Hindi na natin i-discuss ang proof nito, but if you want a discussion of the proof, you can refer to the provided link in our Notion page. So let's move to the next theorem, Dirac's theorem. If G is a simple graph with n vertices and the number of vertices is at least 3, such that the degree of every vertex in G is at least half the number of vertices, then G is Hamiltonian. So ito, madali itong ma-prove using Orr's theorem. So, kung lahat ng vertex ang degree ay at least n over 2, then for all vertices U and V, degree of U plus degree of V will be at least n. No? So here we have two graphs. So let's first look at the first graph. Meron siyang 8 vertices and the degree of each vertex is 4, right? So 4 is half of 8. And so we can use Dirac's theorem to claim that this is Hamiltonian. So this is an example Hamilton circuit for this graph. Ito naman, pinakita lang natin yung circuit to show that it is indeed a Hamilton circuit. How about this graph? Here we have 9 vertices. What is half of 9? 4.5. So, para magamit natin yung Dirac's theorem, dapat lahat ng vertex ay at least 5, which is not the case, no? So, as can be seen, ay uh, lahat sila ay of degree 3 except this one, which is of degree 4. So, anong ibig sabihin yan? Ang sum ng degree ng bawat pair ay at most 7. So, hindi natin pwedeng magamit yung Dirac's theorem, hindi din natin pwedeng magamit yung Force theorem. So, anong masasabi natin? Well, wala tayong masasabi dahil hindi naman na-satisfy yung premise. Right? Although, kung i-observe natin visually, etong graph, madali natin makita na hindi siya Hamiltonian. Bakit? Kasi kahit na anong circuit na magpapass through all the vertices must pass through the center vertex twice. In determining whether a graph is Eulerian or not, we only need to check the degree of the vertices, right? Then we can decide that a certain graph is Eulerian or a certain graph is not Eulerian. So meron bang ganitong property na pwede rin natin magamit para mag-decide para naman sa Hamiltonian graphs? Yung mga nabanggit natin na theorem kanina, makakatulong para malaman kung Hamiltonian o kung hindi Hamiltonian ang isang graph. Pero in all the theorems, wala tayong if and only if condition. So, ibig sabihin, kapag ang isang graph ay hindi na-satisfy ang premise ng theorem, wala tayong mako-conclude. So, ganun yung nangyari dito sa graph na ito, right? In general, ang pwede natin gawin para malaman kung ang isang graph ay Hamiltonian ay mag-generate ng lahat ng possible Hamilton circuit and then trace to see if the circuit exists in the graph. So, yun yung tinatawag na exhaustive search or TAE, trial and error. So far, wala pa tayong alam na general technique for Hamiltonian graphs na hindi gumagamit ng trial and error. So that's it for this lecture video. Thank you for listening.